Morning grade 11s, welcome to Monday morning, May 25th. Today we're going to continue our talk about light. And as I mentioned last week, we are moving into the properties of waves as they relate to light. And so today we're going to be looking at reflection. And then as we move through the week, we're going to be looking at refraction and diffraction of light as those properties of waves as they relate to light. All right, before we get started though, our verse of the day today comes from Psalm 62. And if you have time today, I would encourage you to read all of Psalm 62. I'm going to share the first two verses with you, where it says, "My soul finds rest in God alone. My salvation comes from him. He alone is my rock and my salvation. He is my fortress. I will never be shaken." So take encouragement from that as you go through your day today. And again, if you can read the whole chapter 62 or Psalm 62, it's only 12 verses long. It won't take you very long. And again, just be encouraged by that. All right, reflection. Reflection is a fairly simple concept because again, you are all aware with what the law of reflection says. And you know this. If we had a reflective surface here, let's call it a mirror. Could be anything though. All right, and we have a light ray. Now, when we draw light waves, we just draw them as rays, and rays are arrows. Remember math, a ray is an arrow. And so we're going to draw a light ray that's going to come into here and it's going to hit our mirror. Okay? Light travels in straight lines, and so it's moving into that direction. What we have to know is that when we did our dynamics unit way back when you were actually still here in class, we talked about a normal force. And the normal force was a force that was perpendicular to the surface. With all things, there is a normal line. And with any surface, there's a normal line that is perpendicular to the surface. There's no difference here. And because the normal line is a constant line, we use it to measure from. All right, so here's our normal line. I'm going to draw it as a solid line in blue here so you can see it a bit better on the video. There's our normal line. Okay? And what this gives us is this gives us an angle of incidence right here. Theta I. Okay, incidence is just a fancy word for incoming. Incoming also starts with an I, so if you don't remember incidence, you can remember incoming. Just I is the incoming ray. Now, this light ray will be reflected when it hits the reflective surface. And the rule that has to hold is that it will be reflected in such a way, I did not draw that very well, let me try again. It has to be reflected in such a way, there we go, that's better, that the angle of incidence has to equal theta r. For reflected. All right, so the property, the law of reflection, simply states that theta I has to equal to theta r. Now, this holds true in a whole bunch of things, not just waves and not just light. If you were trying to bounce a ball off the floor to somebody. Okay, the angle that you throw it, the incident angle will equal the reflected angle. If you're playing basketball and you're putting something off the backboard, that angle in has to equal the angle out. If you're playing pool on a pool table, same thing. You hit a ball off the bumper, the angle in is going to equal the angle out. All right, so this is the law of reflection. Anything that's being reflected of any surface. Okay. So now, when we talk specifically about light, there's different kinds of reflective surfaces. Right? So we have mirrors that reflect light really, really well, right? Which is why we can see a reflection. And tomorrow we're going to talk more specifically about mirrors. And we have other things that reflect though, right? If you have a really shiny black table, you can see a reflection in it. In glass, in mirrors, I can see my reflection in the glass of the door. Right? And so there's various things where light reflects off of, sometimes better than others. Light is even reflecting off the surface of the tables in this classroom. or the tables in your house, in your home. And but we don't see our reflection necessarily in them because of the way the reflection is happening. Okay, so there's two types of reflection. There's what's called specular reflection. Okay, specular reflection is where the incoming rays, which are all parallel, okay, so here's our reflective surface. We have some incoming rays that would come in parallel. Okay? And specular reflection says that the reflected rays will also be parallel. Okay, so they will all of them will follow the law. Well, they all follow the law of reflection. And these reflected rays are also parallel. And when that happens, when you have specular reflection, that's when we get a good reflective image, okay, where we can see a reflection in the surface. All right. The second type of reflection is called diffuse reflection. Diffuse reflection. And in diffuse reflection, if we have a reflective surface here and we have incoming, now a diffuse surface is not smooth. So I'm going to draw this like a microscopic view of a surface that is not smooth. Okay, so whereas this one was smooth, this one would not be smooth. And if I have parallel lines coming into it, they will not be reflected parallel. Okay, so this one, again, there's a normal line here, it might get reflected this way. There's a normal line here, it might get reflected this way. If I had an incoming ray coming into here, it actually might get reflected straight back out. And so the reflected lines are not parallel, they are diffused, which means we are not getting a good reflection. Okay, it's not a good reflective surface. So wooden tables, etc., floors are not specular reflection for the most part. I mean, you can have some really, really shiny tabletops and really shiny floors where you can see your reflection in it, but for the most part, they're not. Whereas mirrors and glass and really smooth surfaces would give you a more specular reflection. All right. And so the key points to remember here are that there's a normal line on all surfaces that is perpendicular to the surface, and even here, right, at every point there's a normal line. The normal lines for each of these rays is not the same. Okay, the normal line for here is a bunch of vertical parallel lines wherever the ray is striking, but here they're not parallel, right? They're in different directions, and still each of these rays is following this. Okay, so we have a normal line. The incident ray equals the angle of the incident ray equals the angle of the reflected ray, and yeah, that's what we get. We have specular and diffuse reflections. Okay, that's it for today. What we're going to do today is you're going to do a few questions out of your textbook. You'll find them on page 460, and you'll find the numbers that you need to do on Connect. And in the pages just preceding that, there's again a reading. I've given you a summary of what the reading says. So if you need to, if you're doing the questions and having problems, you can always flip back one page, and you can read a little bit about this. It gives a little more fuller detail than the summary that I've given here. All right. Yeah, that's everything for this morning. Again, if you're watching this in the morning, we do have a Zoom at 11 o'clock on Monday. And so hopefully we'll see you there. If not, we'll see you in another video tomorrow.